Welcome to the next session of derivatives of inverse functions. In the last lecture, we have seen the derivative of inverse trigonometric functions, the formulae and theoretical part. Let us solve some problems using that technique. First problem, using inverse method, find out the derivative of. Y is equal to root x. Using inverse method, we need to find out derivative. We know that if y equal to root x, then dy by dx is equal to 1 upon 2 root x. We want the same answer using inverse method. Let us see how to find out this. Y is equal to root x. We are going to find out its inverse function. Therefore, y square is equal to x. X equal to y square is the inverse of this function. Differentiating with respect to y, dx by dy is equal to 2y. Derivative of y square with respect to y is 2y. But y means root x, that is 2 root x, and therefore dy by dx is equal to 1 upon 2 root, dy by dx is equal to 1 upon dx by dy equal to 1 upon 2 root x. We got the desired answer. Let us take one more problem. Y equal to under root of 2 minus root x. I am taking the problems from textbook only. Y equal to under root 2 minus 2x. Squaring both sides, we get y square is equal to 2 minus root x. Therefore, y square minus 2 is equal to minus root x. Again squaring both sides, y square minus 2 bracket square is equal to x. Now this x is in terms of y, it is the inverse of this function. Let us differentiate this with respect to y. Differentiating with respect to y, dx by dy is equal to, now derivative of bracket square is 2 times bracket square, 2 times bracket into derivative of bracket with respect to y. That is 2 times y square minus 2 into 2y. Derivative of y square is 2y and derivative of minus 2 is 0, which is not written over here. Now y square minus 2 is minus root x. This is 2 into minus root x. 2y is 2 into under root 2 minus root x. Combine these two, we get minus 4 under root 2x minus x. I can multiply these two brackets, root x and root 2 minus root x. I made a mistake here. 2x root x. Now it is correct. Dx by dy we have obtained. We want dy by dx. Dy by dx is 1 upon dx by dy equal to 1 upon minus 4 square root of 2x minus x root x. Let us take one more problem on the same lines. Using inverse method, find out the derivative. Y is equal to e raised to 2x minus 3. the same problem in the textbook. Y equal to e raised to 2x minus 3. Can you tell me what is y then? Sorry, what is x then? For that purpose, you have to take logs on both sides. Log y to the base e is equal to 2x minus 3. Therefore, x is equal to log y plus 3 divided by 2. Differentiating with respect to y. Dx by dy is equal to derivative of log y is 1 upon y, derivative of 3 is 0, derivative of 2 it is constant taken out of the derivative. This is 1 upon y. But y is e raised to 2x minus 3 equal to 1 upon e raised to 2x minus 3 divided by 2. 2 remains. And therefore dy by dx is equal to 1 upon dx by dy equal to 1 upon 1 by 2 e raised to 2x plus minus 3. It is 2 into e raised to 2x minus 3. Let us move to the next problem, which is slightly different. A function is given to us y equal to x square into e raised to x, and we want to find out derivative of its inverse function. Find derivative of inverse function. The given function is y equal to x square e raised to x. Differentiating with respect to x. dy by dx is equal to x square into derivative of e raised to x plus e raised to x into derivative of x square. This is equal to x square into e raised to x plus e raised to x into 2x equal to x e raised to x into bracket x plus 2. Now derivative of inverse, that means we want derivative of x with respect to y, that is we want dx by dy. Therefore dx by dy is equal to 1 upon dy by dx. It is equal to 1 upon x e raised to x into x plus 2. Fine. All the problems in this exercise of 1.2, question number 2, they are similar to this. Whatever function given to you, y equal to some function in x, find its derivative and find derivative of inverse, that is dx by dy is equal to 1 upon dy by dx. All problems are simple problems. We will take one more, but in the third question we will see something from question number 3. Y is equal to x raised to 5 plus 2x cube plus 3x. We want the derivative of inverse of this function at x equal to 1. We want a derivative of inverse function. This function is given to us, its inverse is x equal to something. I don't know what is that at this moment, but I want that derivative evaluated at x equal to 1. The answer is very simple. Y is given, so dy by dx is 5x raised to 4 plus 6x square plus 3. Therefore derivative of inverse function dx by dy is 1 upon dy by dx equal to 1 upon 5x raised to 4 plus 6x square plus 3. Derivative of inverse evaluated at x equal to 1. Derivative of inverse evaluated at x equal to 1. This is equal to 1 upon 5 into 1 raised to 4 plus 6 into 1 square plus 3. That is 1 upon 5 plus 6 plus 3. It is 1 upon 14. Remember that all the problems whose derivative at some particular point required, the answer must be some constant. Here the answer is constant. All the problems in this section are similar. So without wasting time, I am going to skip the problems and they are treated as homework for you. You solve them. If you don't, then if you don't understand the problem, then you can ask me on my WhatsApp number. You know my WhatsApp number 9420050909. Ask me on this number. One more problem from book. Fx is given to us x cube plus x plus 2, and we want f inverse dash of 0. Only the notation is different. Everything is like the previous problem we solved, exactly similar to that. Fx is given to us, so x cube plus x plus 2. Differentiate this with respect to x. We get f dash x is equal to 3x square plus 1. Now we want derivative of f inverse. By the formula, derivative of f inverse x is 1 upon f dash x. dy by dx, dx by dy is 1 upon dy by dx. The same thing but different notation. Equal to 1 upon 3x square plus 1. Equal to, we want f inverse dash evaluated at x equal to 0. So 1 upon 3 into 0 square plus 1, the answer is 1. I hope you can solve these problems very easily. Do them as a homework, as a practice. Solve them, solve more and more problems from many books available in the market, and ask me your difficulties on this WhatsApp number. Thank you.